Hi everyone. Today our topic will be SIP telephony training and some basic scenarios. In some of our previous SIP telephony training, we discussed the basics of SIP and how we configure the core to register with various types of systems. In this lecture, we're going to specifically focus on some of the advanced features that the core provides for different situations. As a quick refresh, here we see a generic SIP network. We have the core, a PC running a soft phone, a SIP proxy, like for example Cisco Call Manager, and a connection out to the larger PSTN network. In your implementation, you may have more devices than this, like network switches, routers, and firewalls. In this example, we're registering to the SIP proxy, and the proxy will respond with an OK message once we're registered properly. Now, let's dive into some things that can happen. Let's change things up a bit. Let's add a firewall between the core and the SIP proxy. The SIP messaging still has to get through the firewall and to the proxy, but the firewall can introduce some problems. On this diagram, we've added some example IP addresses for the devices. The firewall has an inside private IP address that the rest of the world can't reach, and also an outside public IP address. The core will still be configured to register to the IP address of the SIP proxy, in this case 10.2.1.1, but how does the firewall impact what happens next? Moving away from the diagram for a second, here we see a typical registration message from a core. In a few places, we see the SIP proxy address of 10.2.1.1, and we also see a contact line that has the IP address of the core 192.168.0.1. The firewall will pass this message to the proxy, and the proxy will respond. However, there's going to be a problem. We've told the proxy to respond to us at 192.168.0.1. The SIP proxy on the other side of the firewall doesn't know about that IP address. Some firewalls will modify SIP messages so that the response can get back to us, but some will not. In that case, we may never see a response come back since it was sent to an address the proxy can't reach. How do we resolve this? Let's talk about our first feature of this lecture. That's stun. Stun stands for Session Traversal of User Datagram Protocol, UDP, through Network Address Translators, NATs. That is a mouthful. The simple version is that stun allows a system to find out the outside address of the firewall so that SIP messages and calls can get back to us. Here we see the settings on the core for our soft phones. By default, stun is disabled. Let's enable it. Now we have stun enabled, and we see a new box to the right. By default, this box will be blank. A stun server is a server that will respond to a stun message and send back information to us containing the outside IP address of the firewall so we can use it for future messages. Here, we've used a Google server that's commonly used. It's possible that another stun server could be used as well. Now we go back and look at new register messages with stun enabled. We'd see something different. Our contact address has changed to 10.1.1.1. If we go back to our diagram, we'll note that this was the outside IP address of our firewall. Now, our proxy can send messages back to an IP address it can reach, and the firewall will forward them to us. This doesn't just impact registration, it also impacts calls as well. Let's take a look at a real Wireshark capture. Going all the way back to our earlier SIP trainings, we remember that RTP contains the audio stream. In order for both sides to talk to each other, the RTP stream should flow in both directions. Well, here we can see that there's only one RTP stream going out. We don't see one coming back. Why is that? Think back to our SIP messages. In the register message, we had a contact header. In other SIP messages, we recall that they contain SDP, which has the parameters to set up our audio. Here is a snippet of a SIP message showing the SDP info. We have a number of fields here, but the one we're interested in is the C equals line. This contains the IP address that the proxy is supposed to send audio back to, in this case, the core. However, if we didn't enable stun, that IP address is going to be the IP address of the core. As we noted before, the proxy can't reach that address because of the firewall, so our audio is just getting lost in the network right now. If we enable stun, that IP address will change to the outside address of the firewall, and we should get audio in both directions again. If you're behind a firewall and you see issues with registration or audio, try enabling stun and see what happens. There's another flag on the core you may have wondered about, and that's the hold flag. Some systems use an older method of putting a call on hold that just doesn't mesh with the core. The symptoms of this are that when a call is put on hold and then taken off hold, the audio never starts back up. By default, hold is enabled, and that's the normal way we do things. This is what this looks like in a call flow. We see that initially on our call, we had RTP flowing in both directions, but after the call was put on hold, we don't start sending RTP again. This is because when the call was put on hold, we were told to send audio to 0.0.0.0 as an IP address, and then when the call is taken off hold, we're given a new IP address. Unfortunately, this method is not supported by the core, and we end up with one-way audio. If we go back and change hold to disabled, we ignore this, and our call will work normally again. If you're having issues with one-way audio after a call is put on hold, this can be something to try. Another feature you may have wondered about, we have a flag on the core called insecure ciphers. What does that mean? Well, it really only applies if we're using TLS and SRTP. Ciphers are encryption methods. It's basically our method of encrypting our call. If you think about secure websites, it's very similar. When we use encryption, both sides need to agree on what encryption method they're using. As technology has advanced, the need for more secure encryption has as well. This is where this flag comes in. The details don't really matter here, but if you were to open a call in Wireshark or your SIP.txt log and open a SIP message with TLS and SRTP turned on, you'd see a list of lines like this. These are encryption methods that can be used. In our firmware, we've turned off some of the more insecure methods of encryption by default so that everything is encrypted more strongly. However, some providers have not updated their own systems and still use older encryption. Here we've enabled the insecure ciphers flag. This will allow those older encryption methods to be used. If you are having trouble with TLS and SRTP, it might be worth a try to enable this flag and see if it helps. Next, we have the domain-based calling flag. What does this do? Some SIP providers or proxies do additional verification to see if you're allowed to register or make calls by looking at the domain name. By default, the core doesn't use the domain name for all fields in the SIP messaging. Let's enable this flag and see what happens. First thing we should notice is that the domain field, which is normally optional, is now required. In order to use this flag, we must have a domain entered. Enter a domain and save the configuration. Now let's look at what that did. First up, we have a register message with the flag disabled. We can see the domain present in the from and to line, but not the top register line. Now, with the flag enabled, we see that the top line has changed to include the domain as well. This lets our proxy know that this endpoint is from that domain. Here we see a call without the flag enabled. Only the from line has the domain in it. This applies to the invite as well. Here we see that the from, to, and upper invite line all have the domain in them. This lets the proxy know that our call is coming from a domain it recognizes. This mostly applies to hosted SIP solutions, but can be present in other situations as well. That's it for now on more advanced SIP features in the core. These flags can help with more unusual situations that you may run into.